After talking to a scientist who has spent his entire career studying one of the smaller structures inside your body, I walked away with a sentence I haven't been able to shake since. It's not your genes that decide how fast you age. It's tiny structures inside almost every cell in your body called mitochondria, and most of us have never been taught anything real about them, despite the fact that they may be quietly running almost every part of how energetic, how resilient, and even how mentally well we actually feel day to day. I want to take you through everything I learned in that conversation, because it completely rearranged how I think about tiredness, about stress, about aging, and honestly, about what depression actually is at a biological level. I used to think of energy, the way most people do, as something you either have or you don't, something that comes from how much you slept or how much coffee you drank that morning. What I learned is that energy is something your body is manufacturing constantly inside these tiny structures, and the efficiency of that manufacturing process is being shaped every single day by things most of us have never connected to it at all. Let me start with what a mitochondrion actually is, because I think most people have a vague half memory of the word from a school biology class and nothing more concrete than that. Mitochondria are structures that exist inside almost every cell in your body, sometimes described as the cell's power plants, because their job is to take the food you eat and the oxygen you breathe and convert it into a usable form of energy your cells can actually run on. You have an almost unimaginable number of them, and their total health and efficiency across trillions of cells adds up to something like your body's overall energetic capacity. Here's the part that reframed everything for me. Mitochondria aren't a fixed feature you're simply born with in one quantity, like your height. Their number, their efficiency, and their overall health can change meaningfully based on how you live. And the scientist I spoke with described this as one of the most underappreciated facts in all of modern health science. Let's start with stress, because this is where the conversation actually opened, and it's the piece that surprised me the most. Your mitochondria don't just produce energy. Multiple researchers now believe they act as a kind of sensor for your body's overall environment, picking up signals about safety, threat, and stress, and adjusting how they operate in response. When your body perceives chronic stress, not a single stressful moment, but an ongoing, sustained sense of threat, your mitochondria shift priorities, allocating a significant share of their energy output toward managing that perceived threat rather than toward the rest of your body's ordinary functioning. Some researchers estimate that under conditions of chronic stress, a substantial share of your daily energy, potentially more than half of it by some estimates, can end up being consumed by this stress response machinery rather than being available for the things you actually want energy for: focus, mood, physical vitality, immune function. I want to be careful here because that specific number varies across different studies and different ways of measuring it, and I don't want to present a single figure as settled science. What is well established, and what the scientist I spoke with was completely confident about, is the underlying mechanism itself. Chronic stress meaningfully redirects your cellular energy budget away from thriving and toward defending. And that redirection is a real, measurable, physiological event happening inside your mitochondria, not just a vague feeling of being tired. This is where the conversation turned toward depression, and I want to walk through this carefully, because it's a sensitive and genuinely complicated area, and I don't want to oversimplify something that affects real people's lives. There's a growing area of research looking at the relationship between mitochondrial function and mood, and some researchers in this specific field have proposed that at least part of what we experience as depression may be connected to disrupted energy production at the cellular level, rather than being purely, in the way it's sometimes casually described, all in your head. The idea isn't that depression has nothing to do with the brain. The brain is, after all, made of cells too, and an enormous energy consumer in its own right. The idea is that if the cells throughout your body, including your brain cells, are chronically underpowered because their mitochondria are overwhelmed, managing perceived stress and threat, the resulting exhaustion, low motivation, and flattened mood that many people experience with depression might, in at least some cases, have a real physical component sitting underneath it, alongside the psychological and circumstantial factors we usually talk about. I want to say clearly that this is an active, evolving area of research, not a settled explanation for depression as a whole. and depression remains a complex condition with many contributing factors that deserves proper clinical attention rather than a single tidy biological explanation. If any of this is resonating with your own experience, that's worth bringing to a doctor or therapist directly, rather than trying to self-diagnose a mitochondrial cause from a video. But I think the framing itself, considering that low energy and depressed mood might have a genuine physical component worth investigating alongside everything else, is a genuinely useful, compassionate shift away from purely blaming willpower or mindset. Now let's talk about food, because this is where a lot of common assumptions get overturned. Most people assume that if you feel low on energy, the answer is simply to eat more calories in, more energy out, like topping up a fuel tank. What the researcher explained is that this isn't really how it works at the level of your actual cells. Eating more food gives your mitochondria more raw material to work with, but if your mitochondria themselves are inefficient, damaged, or reduced in number, more raw material doesn't translate into more usable energy. It's closer to pouring more fuel into an engine that's already struggling to burn what it has efficiently. In some cases, he explained, overeating relative to your mitochondria's actual capacity can make things worse, not better, contributing to some of the very same feelings of sluggishness people are trying to solve by eating more in the first place, alongside longer-term metabolic strain. What actually improves your energy, according to what he described, isn't simply more fuel. It's more and better functioning power plants, meaning the total number and efficiency of your mitochondria. And that's a completely different problem to solve, one that has almost nothing to do with quantity of food and almost everything to do with a specific set of lifestyle inputs. Which brings us to exercise. And this is genuinely one of the most well-established, well-researched facts in this entire subject. So I want to spend real time on it. Multiple studies on endurance training have shown that sustained aerobic exercise, the kind involved in training for something like a marathon, can lead to a dramatic increase in the number of mitochondria within your muscle cells. In some studies, numbers approaching a full doubling over the course of consistent training. This process, called mitochondrial biogenesis, is your body's direct physical response to the repeated demand for energy that endurance exercise places on your muscles. Your body, quite literally, builds more power plants because it learns it needs them. What struck me about this part of the conversation is how directly it ties everyday physical training to something happening at the microscopic, cellular level in a way that's been rigorously studied and is about as close to settled science as anything in this entire topic gets. You don't need to train for an actual marathon to benefit from this mechanism specifically. The researcher was clear about that. Consistent aerobic activity of almost any kind, sustained over weeks and months, triggers a version of this same adaptive process, just to a lesser degree than the extreme end of endurance training. The next piece of the conversation is the one I found the most genuinely surprising, because it moves outside pure biology into something that sounds, on the surface, like it shouldn't have a physical mechanism behind it at all. The researcher described emerging findings suggesting that people with a strong, clear sense of purpose in their lives appear, on average, to show markers of stronger, more efficient mitochondrial function compared to people who report feeling adrift or without a clear sense of direction. The proposed mechanism, as he explained it, connects back to the stress pathway I described earlier. A strong sense of purpose appears to be associated with your nervous system, interpreting daily challenges and effort differently, more as meaningful engagement than as pure threat, which in turn appears to reduce the share of your cellular energy budget being diverted toward chronic threat management, leaving more of it available for ordinary functioning and vitality. I want to be careful again here, because this is a genuinely newer, still developing area of research. And correlation in studies like this doesn't automatically prove that purpose itself is the direct cause of better mitochondrial function, rather than, say, people with more energy and better health simply finding it easier to feel purposeful in the first place. But several researchers in this space consider the relationship compelling enough to take seriously, and I think it's a genuinely fascinating possibility, regardless of exactly which direction the causation runs, that something as intangible as a felt sense of meaning in your life might have a measurable physical signature at the level of the tiny structures generating your body's energy. The final thread of the conversation moved into something more clinical, and I want to walk through it carefully because it touches on cancer research, and I don't want anything here to be mistaken for treatment advice. For a long time, scientists have observed something called the Warburg effect, named after the researcher who first documented it. Many cancer cells rely heavily on a less efficient method of generating energy, one that doesn't depend as much on properly functioning mitochondria, even when there's plenty of oxygen available for the more efficient mitochondrial process to work normally. In ordinary, healthy cells, this would be an inefficient, almost wasteful way to generate energy. In cancer cells, researchers believe this shift may actually serve the tumor's purposes in other ways, providing raw materials for the extremely rapid cell division that characterizes cancer growth in a way that a slower, more efficient mitochondrial process might not support as effectively. This observation has opened up an entire area of active cancer research, looking at whether therapies that specifically target this altered metabolic behavior, essentially trying to force cancer cells back toward relying on their mitochondria or exploiting their reduced reliance on them, might offer a genuinely new angle of attack alongside existing treatments. I want to be completely clear that this is an active area of scientific research, not an established treatment, and nothing in this video should be taken as medical guidance for anyone dealing with cancer, which absolutely requires care, directed by qualified oncologists working with a person's specific situation. What I found genuinely fascinating is simply how deeply connected this one tiny structure, the mitochondrion, turns out to be to such an enormous range of human experience, from ordinary daily tiredness, to mood, to exercise physiology, to one of the most serious diseases we face. I want to touch briefly on the question of grey hair too, since it came up directly in this conversation, and it's one of the more surprising, tangible examples of how connected all of this actually is. There has been real published research looking at individual strands of human hair, examining sections of hair that correspond to specific stretches of time in a person's life, and finding cases where hair that had turned grey during a period of significant stress showed evidence of regaining its original pigment after that stress was resolved. The proposed mechanism connects back to the same stress and cellular energy pathways we've been discussing throughout this conversation. The idea being that the cells responsible for hair pigmentation are sensitive to the same kind of stress-related disruption affecting mitochondrial function elsewhere in the body, and that under the right conditions, reduce stress and improve cellular energy, that disruption can, in at least some documented cases, be partially reversed. I want to be honest that this isn't a guaranteed, universal outcome, and the existing research on this is still relatively limited and specific, not a proven, repeatable treatment you can expect to work identically for everyone. But it's a genuinely striking, concrete illustration of the larger point running through everything in this conversation, that processes we've long assumed were simply fixed, one-directional features of aging may, in at least some cases, be more responsive to the underlying state of our cellular energy systems than we've traditionally assumed. I want to pull all of these threads together now, because I think there's a single unifying idea running underneath everything I've just described, and it's the idea the researcher kept coming back to throughout our entire conversation. We have spent a huge amount of cultural energy treating aging, energy levels, and even mood as relatively fixed facts about a person, things you're simply stuck with based on genetics or bad luck. What this entire field of research suggests is something quite different. That a meaningful share of how energetic, how resilient, and even how mentally well you feel day to day, and how quickly your body shows the visible and invisible signs of aging, is connected to the ongoing health of these tiny cellular structures, and that health is shaped by things that are, at least to some degree, within your influence. Chronic stress that isn't managed, movement that isn't happening, a sense of purpose that's gone missing. None of these are simple, easy fixes, and I don't want to pretend they are. But the framing itself, that your energy and your aging are connected to a dynamic, responsive, biological system rather than a fixed sentence handed down by your genes, is, I think, one of the more genuinely hopeful reframes to come out of this entire area of science. So let me try to turn this into something you can actually use, because I don't want to leave you with just a fascinating set of facts and no direction. Here's what I've come to believe after this conversation about how to actually support your own mitochondrial health in ordinary, practical terms. First, take chronic stress seriously as a genuine physiological issue, not just an emotional inconvenience to push through. Whatever actually works for you, whether that's therapy, structured downtime, breathing practices, or simply protecting more unstructured rest in your week, treat managing chronic stress as directly connected to your physical energy levels, not separate from them. Second, move your body consistently and understand that you're not just burning calories or building visible muscle when you do. You're directly triggering your body to build more of the cellular machinery responsible for your baseline energy levels, a benefit that compounds over weeks and months of consistency far more than through occasional intense effort. Third, rethink the instinct to simply eat more when you're feeling low energy, and instead pay attention to whether the deeper issue might be about the efficiency of your energy production rather than the raw quantity of fuel going in. This isn't a call to restrict food, it's a call to notice that persistent fatigue despite adequate eating is a genuine signal worth investigating, potentially with a doctor, rather than something to simply out-eat. Fourth, take an honest look at whether you have a genuine, felt sense of purpose in your daily life, separate from simple productivity or achievement. Given the emerging research connecting purpose to cellular energy function, this isn't just an abstract, feel-good question. It may be a genuinely physical lever worth taking as seriously as diet or exercise. Fifth, if you're dealing with persistent low mood or exhaustion that isn't responding to the ordinary things you've tried, bring the possibility of an underlying physical or metabolic component into the conversation with your doctor, rather than assuming it must be purely psychological or purely a matter of willpower. This emerging research doesn't replace proper mental health care, but it may add a useful additional angle worth exploring alongside it. I want to end with something the researcher said toward the end of our conversation that has genuinely stayed with me. He said, "We've spent generations treating fatigue, low mood, and aging as things that simply happen to us, forces outside our control, written into our genes at birth." But he said the deeper you go into the actual cellular machinery producing your energy, the more it starts to look less like a fixed sentence and more like an ongoing conversation, one your body is having every single day, with how you live, how you move, how you manage stress, and whether you feel your life has genuine direction. None of that makes aging optional, and none of it replaces real medical care when something is genuinely wrong. But it does mean that some of what we've long assumed was simply out of our hands may actually be far more responsive, far more alive, and far more within our influence than most of us have ever been taught to believe.